Yeah, a very good evening, everyone. So we'll start now, and today we are going to discuss fish processing technology. So we thought like fish processing technology, as we know, FRM, aquaculture, and fish processing technology, they are most important in terms of scoring, in terms of questions. The weightage will be more. So means if you take AEM, economics extension, the weightage will be less, and more or less they will be more focused and concerned in the fish processing technology. So we have divided the topics, and we have went through the previous year's questions, the last 10 years questions. So we felt like some of the topics need to be emphasized, some memory based topics, uh, some numericals, some the temperatures, means processing. So we have divided the topics, and first part will be dealt by Sahana, and the second products byproducts will be dealt by me. And yeah, now like first at the beginning, Sana will share the microbiology, the bacteria, the products, all these things. And with this, I would like to start the session, and the first speaker, Sahana. Her name is Sahana, and she's currently doing her PhD in CIFE. She has about to finish her first year, and she has did her masters in CIFE itself. She did her undergraduation from Mangalore. So with this, I would like to start the session. Sana, can you over to you? Can you start the
Yeah,
session?
sure, sure. Hi everyone. I have introduced myself, so you hope you all know that my name is Sahana, and someone is sharing. I don't know who is that.
Someone quizzo, please stop presenting.
Yeah, that's fine. That's fine. So today we're going to talk about the basic aspect of the processing, so that it's almost like a brush up thing. So most of the things you know are like we are trying to deal the minute parts which we make it confused, so that we are going to get a clear idea about those parts. So I'll start my slides now. Is my slides visible?
Yeah, they are perfectly visible. You can go on.
Yeah, hello. So first we will talk about the biochemistry part, and among that we are going to talk about the approximate composition of the fish. So we all know the fish has got high amount of the protein, which ranges around between 50 to 24%, and it has got less amount of the carbohydrate, which is around 0.1 to 1%, and the lipid ranges from 0.2 to 6 to 7. And you know the lipid and water, they have an inverse relationship. That means if a fish has high amount of lipid, the water content will be less. And the minerals in the form of ash, when we detect, they are obtained at a range of 0.4 to 2%. And so let us see these composition in detail. First, if you want to talk about carbohydrates, can anyone put in a comment section what is the energy we obtain from 1 gram of carbohydrate, and what is the molecular formula for general molecular formula for carbohydrate? So the Chanikya, you can check in the chat box, so that we'll have a bit of interactive session. So the general formula of carbohydrate comes like CnH2O and Y, and that is the AC represents the number of carbon atom and Y represents the number of H2O atoms in that compound. And usually on hydrolysis of carbohydrate, you get aldehyde and ketones. And then 1 gram of carbohydrate will provide us 4.2 kilocalories. And the major carbohydrate which is present in the fishes is in the form of glycogen. And compared to fish, the carbohydrate content in case of mollusks, especially in case of shrimps, it is very high. And that again ranges from 1 to 7%. And again, if that is why the shrimps, they have got sweet in taste. So if you go for classification of carbohydrate, they are divided into monosaccharides, oligosaccharides, and polysaccharides. So the monosaccharides, they do have a carbon atom number between 3 to 8. So again, they are divided into aldose and ketose, and further they are divided into triose, tetrose, pentose, hexose, and heptose. And oligosaccharides are the one which are obtained from the combination of monosaccharides. free monosaccharides as such. In case of polysaccharides, it may be formed from combination of oligosaccharide or combinations of monosaccharide. So again, this is very important, like homopolysaccharide and heteropolysaccharide. So the homopolysaccharides, the number of the compounds, the polymers which are repeated in the homopolysaccharides are same. For example, in starch, what is the starch? Starch is nothing but it is a homopolymer of glucose. If you're talking about the hyaluronic acid, they don't have a same compound which is repeated again and again. In case of hyaluronic acid, the compounds which are repeated it is made up of glucuronic acid and N-acetyl glucose. Can anyone tell whether chitin is a homopolysaccharide or heteropolysaccharide? Chitin, whether it is homopolysaccharide or heteropolysaccharide. And in case of the oligosaccharide, as I told, disaccharides, there are maltose, lactose and sucrose. So the maltose is composed of repeating units of glucose and glucose. Lactose is made up of glucose and galactose. And I think the other one is, there's some mistake in that. And the disaccharide, in that raffinose is made up of glucose, fructose and galactose. In case of tetrasaccharide, again it is made up of 4 carbon atom. Example, we have got stacchylose, it is made up of galactose, glucose and fructose. So another important question that we get from this carbohydrate part is glycolysis, glycogenesis, glycogenesis, all those things. So let us study what are they. So as you can see in the name, glycogenesis. So there is a synthesis of something from there is a synthesis of something. So what is synthesized? Here the glycogen is synthesized. So we are obtaining glycogen from glucose. That is, glucose is converted into glycogen. There is a synthesis of glycogen. That process is called as glycogenesis. Next we are having glycogenolysis. So lysis means what? That's a breakdown. So the breakdown of what? Glycogen. So once you are having the breakdown of glycogen, we are getting glucose. So glycogenesis is the genesis of glycogen. Glycogenolysis is the breakdown of glycogen. So as a result, we get glucose. So what is glycolysis? So again there is a breakdown. Here you can see the glycogenolysis is there, but here there is only glycolysis is there. So in case of glycolysis, there is the breakdown of glucose in order to obtain ATP and pyruvate. So in case of glycogenolysis, there is a breakdown of glycogen. In case of glycolysis, there is a breakdown of glucose. Next is glyconeogenesis. So the gluconeogenesis. Again, there is a word called as genesis. Here the word is glucogen. Here the other word is called as gluco. So here there is a synthesis of glucose, but we are obtaining glucose from non-carbohydrate sources such as the fatty acids and also the amino acids. So these are the terms which you have to remember. So they may be a bit confusing. If you understand the words properly, I think it will be easy for you to say. And for my before question, so the chitin is a homopolysaccharides of N-acetyl D-glucosamine. So next let us talk about the Browning reaction. So you know very evidently the Browning reaction is divided into enzymatic Browning reaction and non-enzymatic Browning reaction. So enzymatic Browning reaction, as the name says, there is a presence of enzymes that causes the Browning reaction. So the example for this is we are having phenolase enzymes. In case of non-enzymatic Browning reaction, or it is called as Maillard reaction, so the one which you see in case of buns or the bread items. Here there is a reaction between the amino acid and the reducing sugar. Because there is a reaction between a sugar and amino acid, that results in the formation of a brown color compound. That is non-enzymatic reaction. Here in non-enzymatic reaction, you are having two compounds, presence of heat, that causes the browning. In case of enzymatic Browning reaction, we have enzyme because of which we are having a brown color formation. So next let us talk about water. So you know the water and liquids are inversely related in case of the fish, and so you know the fish which contains highest amount of water, that you can put it down in the comment section. So the water is dipolar in nature. So the dipolar moment of water is 1.83 decibels, and so the bond angle again, the bond angle is very important. So the bond angle between this water is 104.5 degree. and the bond length between oxygen and hydrogen atom is 5.7 picometers, and the energy obtained for the formation of this OH bond is 450 kilojoules per mole. So next, one important terms when you talk about water is water activity. So the water activity is nothing but it is the water which is available in a food for the bacteria or for any of the microorganisms. In short, it is the water available in a food item that can be utilized for other purpose. Usually they ask the water activity formula. So it is represented as vapor pressure of water in a substance divided by vapor pressure of a pure water. And you always have to remember this water activity. Whenever you are given a formula, when you write the formula, when you have to calculate the water activity, you should always remember that the temperature has to be constant. Because if there is a change in temperature, the whatever value you are getting or whatever the statement you are putting, it may not be correct. So then we have got, let us see about latent heat. So you know latent heat of fusion, latent heat of sublimation, latent heat of vaporization. So what is latent heat? Latent heat is basically you are changing the state of substance without changing the temperature. So what is specific heat? So let us see the difference between the latent heat and the specific heat. In case of latent heat, you are trying to change the state of the matter. That means you are trying to change from solid to liquid, from liquid to gas, etc. etc. In case of specific heat, you are trying to increase the temperature of the substance without altering the state of it. That is specific heat. So latent heat of fusion of ice. These terms are important. It's you just have to memorize these terms because these are the basic things. Chances are they may come, they may not come, but you should. And these are very useful for your future studies also. So latent heat of fusion ice is 80 calories. For latent heat of fusion, in case of the frozen fish, it is 56 kilocalories. That is fusion means there is a change from solid to liquid. Latent heat of vaporization of water, that is change from liquid to gas. It is 533 calories per gram. Sublimation means you all know about sublimation, changes from solid directly into vapor. There is no middle state such as liquid. From solid to vapor, that is sublimation. That is around 66 kilocalories. So now let's talk about specific heat. So what is the specific heat of water? So you all know, I guess, the specific heat of water is 1 kilocalories per kg. The specific heat of fish, again it depends upon the temperature what you are subjecting the fish. So if the temperature is around 30 to 0 degrees Celsius, it's like the normal temperature of the fish, you can assume the specific heat will be around 0.74 to 0.91 kilocalories. In case of chilled fish, it is around 0.845 kilocalories. In case of frozen fish, it is around 0.440 kilocalories per kg. So you all know when you freeze the fish, the time taken, if you are talking about IPF, it is around 30 minutes, or if you are talking about other type of freezer, it will be between 45 minutes. Okay. So why the freezing takes place very fast when compared to thawing? When you thaw the fish, you actually require more time. You just have to keep in running water and you have to wait like 2-3 hours. So the reason for this is the thermal conductivity. So the thermal conductivity of the ice is more when compared to water. That is why the freezing will take place in a very short time. It takes place around between 30 to 45 to 1 hour. But when you go for thawing, because the water conductivity of water is 0.52 kilocalories per minute per hour per degree Celsius. So that takes a lot of time. So that is the reason. And then the relationship between water activity and equilibrium relative humidity. Again, this question may also come. So the relationship between water activity is usually expressed in terms of 1 to 0. Like the value will be between 0.1, 0.2, 0.9, etc. So when you multiply that by 100, you will get the relative humidity. That means what is the moisture present in the atmosphere in which you are keeping the substance. That is the equilibrium relative humidity. Next, these are the water activity, different water activity, and what are the microbes that are inhibited. So the first one, it's like the fish has a water activity almost around that of water. The water activity of water is around 1. The fish is around 0.9 to 1. If you talk about microbes, At 0.95, most of the gram-negative bacteria, all the gram-negative bacteria are included. The gram-positive bacteria are a bit strong compared to gram-negative. They can resist up to 0.91 water activity. And then comes the yeast, mold, and staphylococcus. The staphylococcus value you should remember, it is 0.80. And then, so can anyone tell whether staphylococcus is a gram-positive or gram-negative bacteria in the comment section? And then halophilic bacteria are around 0.75, and xerophilic molds are 0.65, and osmophilic yeast are 0.60. So again, it depends upon the the food, the item, everything. The water activity varies, and based on the water activity, we can see it is microbes. So again, if you are talking about the lipids, the fish again is divided into lean, semi-fatty, and fatty fishes based on the lipid content. If it is less than 0.2, it is called as lean fish. If it is between 0.5 to 2, it is called as semi-fatty fish. And if a fatty fish has got more than 2% of lipid, and you all know that lipid and water are inversely related. So if it is a lean fish, obviously it has got high amount of the water in it. So again, lipids are divided into two types, that is simple lipids and the compound lipids, which I guess you have already heard about the name triglycerides and also the phospholipids. The phospholipid spelling is wrong. I'll just correct it when I send you all the PDF. So lipids are nothing but they are the esters of the fatty acids along with the glycerol or alcohol. That is the definition for the lipids. So what are triglycerides? So triglycerides are nothing but they are the esters of glycerol. And what are phospholipids? Then they are also the esters of glycerol. In here, one of the glycerol OH group is esterified by the phosphoric acid. That means same, they have almost similar structure as the triglyceride, but in one of the OH group of glycerol, it is replaced by the phosphoric acid. That's the difference between triglycerides and phospholipids. Again, the triglycerides, they form a major portion of total lipid in case of a fish. And when you come for the energy source, the triglycerides, they are the energy source for the fish, and they act as a storage liquid. So they are also called as depot fat because they are the energy source. In case of phospholipids, they form majority of the lean muscles. Like they are found mostly in, or majority of the lean muscles is made up of phospholipids, and they form a major portion of unsaturated fatty acids. And again, it is divided into lecithin and cephalin, which is again important. Those two terms, lecithin and cephalin, and they, as we know, triglycerides, they form the storage lipid, and phospholipids are associated with the structure and function, the structure of the structure and the cell membrane of cell membrane. They're mostly associated with that thing. So if you are talking about the energy value, that is obtained by lipid, carbohydrate, and protein, they are as follows. So lipid you will get around 4.5 kilocalories per gram. Proteins you obtain around 5.6 kilocalories per gram. In case of carbohydrate, you will obtain around 4.1 kilocalories per gram. When you come to the classification, you already know they are divided into essential fatty acids and non-essential fatty acids. And essential fatty acids is the one which is required for your body. And then again it is divided into saturated fatty acids, non-saturated, unsaturated fatty acids. So the saturated fatty acids are the one which contains only one bond. It doesn't have any double bond. When if there is the presence of double bond, that is called as unsaturated fatty acid. And one more thing is that saturated fatty acids are solids at room temperature, and unsaturated fatty acids are usually liquids at room temperature. So here we are having a list of saturated and unsaturated fatty acids. And the unsaturated fatty acid, again it is divided into monounsaturated and polyunsaturated based on the double bond. So this is the carbon atom, and these are the double bonds. So you can see in saturated fatty acids there is no double bond, so they are represented by 0. So example for this is myristic acid, palmitic acid, stearic acid. If you are talking about monounsaturated fatty acid, we are having oleic acid, and here down I have written that this palmitoleic acid. They contain 18 carbon atoms, 16 carbon atoms, and they have only one double bond. So what is this omega 9, omega 6, omega 3, all these things? So that represents the position of the double bond from the methyl group. That's the N-methyl group. From that, from where the double bond will start to form, it is located. That is represented by omega 9, 6, and 3. So again, the fatty acid is divided into eicosapentaenoic acid, docosapentaenoic acid, and omega-6 we are having arachidonic acid, linoleic acid. That you know, and you know the functions also. Eicosapentaenoic acid and docosapentaenoic acid are very important, and they also are important for the brain and heart related diseases. And next we will talk about the spoilage and lipids, that is oxidative rancidity, hydrolytic rancidity. So as the name represents, so the oxidative rancidity means there is oxidation. So oxidation of unsaturated fatty acid that results in oxidative rancidity. When there is hydrolysis, that causes the hydrolytic rancidity. As the name represents, in case of oxidative rancidity, the spoilage is because of oxidation. In case of hydrolytic rancidity, the spoilage is because of hydrolysis. So what are the end products? So obviously if it is rancidity, it is not a good thing. So whatever the end products are formed, they have a negative impact on our oil and they causes the spoilage of our oil, or deterioration or anything of related to the oil is because of those compounds. So if you are talking about oxidative rancidity, there is a formation of aldehyde, ketones and peroxides. In case of hydrolytic rancidity, usually it results in the formation of free fatty acids. So again, these two terms are important. And this is just the definition. So what is acid number? So the acid number represents the acidity of that oil or fat. That means the milligram of potassium hydroxide that is required to neutralize the acid that is present in the 1 gram of fat or oil. In case of iodine number, which is again important, it will determine the unsaturation, degree of unsaturation in a liquid. So higher the iodine number, higher is the degree of unsaturation. That is the number of gram of iodine that can be consumed by 100 gram of fat or oil. So you all know about saponification. So saponification will yield us what? So it will yield us soap. So basically we use saponification to obtain soap. So if if your oil is having high saponification value, then we usually use it to produce soap. So that is milligram of potassium hydroxide needed to saponify 1 gram of fat. Down they have given the explanations, such as if you take a fat such as a triglyceride in the presence of sodium hydroxide or potassium hydroxide, upon saponification it will yield glycerol and soap molecules. So next let us see about vitamins. So again, vitamins are divided into two parts, that is fat soluble vitamins and water soluble vitamins. The name itself is explanatory. The vitamins are soluble in fat, the vitamins are soluble in the water. So fat soluble vitamins, we are having A, D, E, K, that is vitamin A, D, E and K. So vitamin A is also called as retinol or retinoic acid. Vitamin D, we are having D2 and D3, that is ergocalciferol or the cholecalciferol. Vitamin E, it is called as tocopherol, which you all know, which is having high antioxidant property. And vitamin C, we are having phylloquinone and minoxidil, that is K1 and K2. So the third part is the one, the deficiency caused by this vitamin. So if you have a deficiency of vitamin A, so which is retinol, as the name itself says, something related to eyes, so that causes the night blindness or something related to eyes. In case of vitamin D, you all know you stand near the sun, or the sun is a very good source of vitamin D. So if you don't get proper amount of vitamin D, then that again results in something related to your bones or the body. That causes the rickets and also the osteomyelitis. It again causes the hemolytic anemia, that means there is less loss of blood in case of, especially seen in case of newborn infants. Next we are having fat soluble vitamins. So you do have to remember these names: B1, B2, B3, B5, B6, B7, B9 and B12 and C. You all know vitamin C, which is the ascorbic acid or a citric acid. So these are the names. B1, it has got green thiamine. B2, it is called as riboflavin. B3 is called as niacin, and so on. So again, so vitamin B1 that results in the disease called as beriberi, and if you don't have a proper amount of vitamin C, that causes the squamous problem. So I think among this you should remember the vitamin names along with the B1, B2, what are the chemical names of the vitamins. and some of the diseases are also very important. In case of fish is a good source of fat soluble vitamins. In that especially it is a good source of A, D, E, and it too has got the water soluble vitamins, all the B complex vitamins. And then fish liver oil is a great source of vitamin A and D, and vitamin A is found around 300 IU per gram. In case of vitamin D is found around 250,000 Ig per gram of your liver. And fish oil is a rich source of vitamin E, that is tocopherol. So again, this is the same extension of it. So as you can see here, the vitamin A, it has got importance with the vision. Vitamin D has importance with the calcium, and the vitamin E, the one which we all know that is an antioxidant. Vitamin K has a role with the blood clotting. Next, in case of water soluble vitamins, you should also remember sometimes they may ask the coenzymes, but I think the coenzymes are almost related with the name of the vitamins, so I think that may be easy for you to remember. So next, let us talk about protein. So we all know proteins has 4 structures, that is primary, secondary, tertiary, and quaternary structure. So the primary structure is nothing but the simple form of protein is nothing but its primary structure. So we know protein is a nitrogen containing compound having high molecular weight, and it contains a repeating amount of amino acids. And the bond present, what are the bonds present in protein, or the bond which joins two amino acids, like the bond which joins two amino acids in a protein. Can anyone put in the comment section? Comment section. Yeah. So we are having 4 structures: primary, secondary, tertiary, and quaternary structure. So the primary structure is the simplest form, where you have got amino acid and they are linked by peptide bond. It is almost in the form of a straight chain. In case of secondary structure, as the number of carbon atoms start to go on increasing, they will start to arrange and they will start to form bond between with one another. That causes the formation of alpha helix or beta placket. That is the rotation of carbon around the axis. So because of that rotation, there is a formation of this bond. In case of primary structure, you can see only the formation of peptide bond, because there is only peptide bond formed as the protein is in a state structure. So between amino acid, you can see the formation of peptide bond. In case of secondary structure, because the number of carbon atoms are increasing and the carbon will start to try to form bond with others, there is a formation of both hydrogen bond and also the peptide bond. In case of tertiary structure, you can see almost both covalent and non-covalent bonds, such as with a disulfide bond, van der Waals attraction. All these things are found in tertiary structure. The quaternary structure is nothing but it is the spatial arrangement. When the 2-3 tertiary structure come together, they form the quaternary structure. So, can anyone comment what are the covalent bonds and non-covalent bonds present in protein? So next, talking about amino acids. So again, they are divided into essential, non-essential, and conditionally essential. So the conditionally essential also comes under the non-essential part, and there are 20 amino acids, and you do have to remember those amino acids names. So I think you can find the short words or the keywords in Google or in YouTube in a better way to remember those names, which are again very important. So coming to the bonds, so the covalent bonds are peptide bond and disulfide bond. So non-covalent bonds are the hydrogen bond, hydrophobic interaction, or you can also call it like hydrophobic interaction, ionic interaction. And can anyone tell how the disulfide bond is formed in the comment section? What compound is responsible for the formation of disulfide bond in the proteins? So again, the amino acids are divided into non-polar, polar, acidic, and basic. So in case of basic, we are having lysine, arginine, and histidine. Acidic, we are having aspartic acid, glutamic acid, and polar and non-polar. So both acidic and basic, they are charged. Polar are non-charged. In case of non-polar, they are not charged. But polar are not charged, fish has got high amount of lysine. So can anyone tell what are the limiting amino acids present in the fish and what are the aromatic amino acids present in the fish? So coming to my bigger question, so because of the presence of cysteine, that is sulfur-containing amino acid, that results in the formation of the disulfide bond in the protein. So lysine and methionine are the limiting amino acids. So you can see these two sentences are a bit contradictory. The fish is a rich source of lysine. At the same time, the limiting amino acid which is present in the fish is lysine. That is because the lysine is not very stable. So once the fish dies, the chances of lysine to get lost in the form of it get lost is high. In case it is high, so it comes under the limiting amino acids. So for the aromatic amino acids, we are having tyrosine, phenylalanine and tryptophan. So again, coming to the classification of proteins, based on the solubility, they are divided into three types of proteins. We have three types of mother proteins, that is myofibril protein, sarcoplasmic protein and stoma protein. So can anyone tell, put in comment section, what is the percentage of myofibril protein, sarcoplasmic protein, stoma protein present in fish? So coming to the myofibril protein, you all know this is the protein which is the structural protein, the one which is related with the muscles and the one which is related with the gel formation, that is the myofibril protein. And it is extracted with the help of salt, more than 0.5 molar ionic strength. And the concentration of the myofibril protein in case of the fishes is around 65 to 75% of total protein. So this myofibril protein is very important because this has a major role in muscle contraction, and most of the products what we are preparing from the fishes, such as surimi or any other thing, surimi and sausage, other things are all they are nothing but they are the concentrated form of myofibril protein, and the important property which holds all those products is the gelation. So the myofibril protein plays a very important role in the product development, and the property that is responsible for those product development is the gelation. So next, coming to the myofibril protein, it is composed of myosin, actin, tropomyosin, troponin. Again, tropomyosin is troponin is divided into troponin C, I and P, and they do have other minute protein in the form of dexamine, actinin and nebuline that ranges from 1 to 5%. So you can see the percentage of myosin, actin present in the myofibril protein. Myosin is present around 50 to 60%. Actin is present a bit less, that is 15 to 30%. Both tropomyosin and troponin are present 5 and 5%. So that is the molecular weight of the myosin and actin. So the myosin molecular weight is very high, it is around 500 kilodaltons. In case of actin, it is between 43 to 48 kilodaltons. In case of tropomyosin, we are having 65 to 70 kilodaltons, and troponin, CIT, these are the sizes of those proteins. So we know myosin, the myosin it forms the major portions of the myofibril protein, and the myosin is a thick filament, and actin is a thin filament. So the myosin is again composed of 6 polypeptide chains. It is again made up of 6 chains. In that, 2 are heavy chains and 4 are light chains. These are the length and diameter of the chain. So both are having the same length, that is 1 to 2 micrometer length. The thickness is, for the heavy chain it is 16 nanometer, and for the light chain it is around 8 nanometers. And myosin as such, it is myofibril protein as such, they are soluble in more than 0.5 molar ionic strength. In case of myosin, it is soluble around 0.52 molar ionic strength. Again, this point is a bit important. They had asked in last time, I think, SRF question, I guess, the solubility of myosin protein. And so the myosin is again responsible for the movement, that is, it has got in its head ATP that helps in the conversion of the ATP, so that there is a production, there is a movement or the energy production is there. And if you subject the myosin to the enzyme such as the trypsin and chymotrypsin, you get those light sediment and heavy sediment. Again, if you subject them for propiling, you will get S2 and S1 part. So the head part is the one which has got most of the activity when compared to that of the tail part. Next is actin. So actin exists in two forms, that is F and G actin. So the G actin is usually it's in the form of a single. If the monomer is called as G actin, when the G actin combines together, when they polymerize, that is called as F actin. I hope you are all aware of this structure. So I'll just try to explain it a bit fast. So you can see here, this is the light chain and this is the heavy chain, or the one which are having, the more they have got higher diameter. So this is actin, the one which is in blue color. The brown color is called as myosin. That is how they are arranged in order to form like a striated structure. So the between this zone is called as I band, from between the starting which consists of mostly the actin between the two myosin, that is called as I band, which is also called as isotropic band, or which is usually light color. The one between the myosin actin together, that is called as A band, which is also called as anisotropic band, or which is usually dark in color. So this I band is divided by a line which is called as Z line, and the A band is divided by a line called as M line. So you do have a zone here which only consists of this myosin compounds, that is called as head zone, and which usually consists of only thick element, that is the myosin. So this is the structure of actomyosin. So again, troponin and tropomyosin, this is regarding muscle contraction. I try to explain it very fast. You all know okay.
Kalairasi, can you mute yourself? Kalairasi, can you mute yourself? Yeah, continue, Sahana.
phone பண்றா என்னடி இல்ல இப்பதான் எல்லாம் phone பண்ணுவாளுங்க.
Hello, am I audible? Hello, hello.
phone பண்ண கவிக்கு.
Hello, am I audible?
Yeah, continue. She has left, you continue.
Okay. So regarding the muscle contraction, so we all know the muscle contraction requires the presence of calcium. So what actually happens within the presence of calcium? So we know the compounds such as the troponin and tropomyosin, which are very much important for the muscle contraction. So the troponin function is to hold the tropomyosin in a proper position. So this tropomyosin is in it usually will be associated with the actin, and placing the tropomyosin in the position, that is the role of troponin. So again, troponin is divided into troponin I, troponin T and troponin C. So what is the function of troponin I? So the troponin I, it helps in binding the actin so that it will hold this actin tropomyosin complex. As I told, the main function of troponin is to control the tropomyosin's bonding or the position in the actin. So when the troponin I, it will bind to the actin, it will keep the actin tropomyosin complex in proper position. So troponin T, it helps in proper binding, or like it will help in proper interlocking of that complex. So troponin C is the one which will show its movement based on the presence of calcium. So when the troponin C will bind the calcium, which in turn it will send the signals to T and I. So the tropomyosin will move, it will open and close. Based on that movement, the muscle will contract. For example, when there is a presence of calcium, so the calcium will go and bind to troponin C. That causes the movement of actin tropomyosin complex by the troponin I. So because it is moved, the actin can bind with the myosin, and there is a muscle contraction. The actomyosin is formed, muscle contraction takes place. So when there is no calcium, there is no calcium, the tropomyosin doesn't bind with the calcium. So the troponin I, it will move the actin tropomyosin complex, So that causes the relaxation. That means during relaxation there is no binding between actin and myosin. That again is controlled by this troponin, which controls the position of tropomyosin. That gives the way for the binding of myosin to actin. Next comes the sarcoplasmic protein. So sarcoplasmic protein, as you all know, they contains of the enzymes. Usually they are soluble in the ion strength of having less than 0.15 molar. So the concentration of the amount of the sarcoplasmic protein which is present in the fishes is between 25 to 30%. It's higher in pelagic fishes, lower in demersal fishes. It is found high amount in dark mussels. So these are not one which are associated with the gel formation. So you usually remove sarcoplasmic protein whenever you are trying to form surimi or sausage, because they do have adverse effects. As the name suggests, they are mostly composed of enzymes. They doesn't help in the formation of good gel. So you do remove them whenever you are trying to form any products which are having high gel strength. Next, with the stroma protein. The stroma protein forms 3% in case of teleus. In case of elasmobranchs, it is around 10%. In case of mammals, it is around 7%. So the stroma proteins are the ones which are nothing but they are the connective tissue, and it's very rare to extract them. So in case of sarcoplasm, you use low ionic strength. In case of myofibril protein, you use high ionic strength. In case of stroma protein, you should use you cannot. It is not very possible to easily extract them. You should use a high concentration of either, for example, if you want to extract collagen, then you have to use acid which are having very low concentration, very high pH, or if you want to use alkali, again having high pH. Only at extreme points you can extract the stroma protein, which is very difficult to extract. So the stroma protein is composed of collagen, elastin, and elastin is usually resistant to heating and cooking. And when you talk about collagen, when the collagen is converted, when you heat it, it will form into gelatin. And the fishes collagen, they do have a they are very heat sensitive. They don't have a high stability in temperature. So the chances of them getting converted into gelatin is very high. And so most of the products we obtain fishes are associated with gelatin, because to maintain the fish more than 20 degrees Celsius with collagen is a bit difficult task. So you obtain most associated gelatin products. Next, coming for Npn compounds. So the Npn compounds are nothing but these are the nitrogen containing compounds, same as the protein, but they are not the protein. That means they are having low molecular weight. Again, both proteins and non-nitrogen compounds both contains nitrogen, but NPNs are not the proteins. And they are present around 9 to 18% in case of teleus, 33 to 38% in case of elasmobranch, and NPN are more in dark mussel when compared to that of the white meat. In case of mollusks, it forms around 20 to 25%. And these are the ones which impacts a unique taste to your seafood, or like the ones which are responsible for maker or other things of that means they give the essence for the seafood. And again they are divided into, there are many types such as the TMAO, ammonia, or Benedictine compounds, or the nucleotides, or the imidazole compounds. So these are some points. We can go through it. Some of these points may be asked. So I have just included as a pointer, you can just read it just for information sake. So in case of free amino acid content in the seafood is around 0.5 to 2%, and the crustacean has got higher amount of the free amino acid content. So if you are talking about free amino acid, so you have got amino acids such as the histidine, which are again present high amount in the pelagic fishes such as the tuna, mackerel, and mahi-mahi. And then the glycine content in case of prawns or the shrimps are very high compared to the crabs. Because of that, they get the sweetness. So the glycogen content ranges from 1 to 7%. The glycine content is around 1%. And then the dark mussel contains more peptides than compared to the white mussel. And next is regarding the Benedictine compound. These are the values just for your reference. Next is urea. So the urea in case of teleus is low when compared to the elasmobranch. Again, you all know urea is required for the osmoregulation. And in case of teleus, it is less than 50 mg per kg. In case of marine fishes, it is between 1 to 2.5 gram per kg. The TMAO in case of marine, TMAO is not evident in case of freshwater fishes. It's only found associated with the marine fishes because they act as an anti-freeze compound, and in case of marine teleos, it is present between 50 to 250 milligram per kg. In case of elasmobranchs, it is present between 1000 to 1800 milligram per kg. And the degradation of TMAO that results in the formation of formaldehyde. So that pungent smell, whatever you get in a fish, it also results because of the formation of formaldehyde. Next is regarding the amines. So the amines are nothing but they are also the nitrogen compound. So the amino acid, when you try to remove the carbon from them, that when you go for remove the carbon, that is decarboxylation, that results in the formation of the biogenic amines. So this conversion or these terms are very important, such as the histidine is the amino acid and histamine is the biogenic amine which is formed from the histidine through the process called as decarboxylation. What is decarboxylation? It is nothing but removal of a carbon atom from the amino acid that results in the formation of the biogenic amines. So histidine results in the formation of histamine, tyrosine results in the formation of tyramine, tryptophan, tryptamine, lysine, cadaverine, and then you have no ornithine, it will give the product called as putrescine. Next, regarding the changes in the chill fishes. So these are just for reference. I think you get these things from FAO also. So first let us look at the second table. From TMAO, you will get TMA product. Then it will decompose from the H2S. And methionine it reduces to form the sulfur containing compounds. In case of carbohydrate, you get acetic acid formation. Inosine and IMP results in the formation of hypoxanthine. So you know hypoxanthine. What does the hypoxanthine signature or the hypoxanthine presence? It indicates what? Whether it indicates the freshness of fish or whether it indicates the spoilage of fish. Can anyone comment in the comment section? So ammonia, amino acids and urea result in the formation of ammonia. And here it is this is very important. Second box is important. They too may ask that. In case of second one, it is for your understanding. The glycogen in the presence of glycolytic enzyme that results in the formation of lactic acid, especially through the anaerobic respiration and when the fish dies, obviously, and that causes the decrease in the pH because there is the production of acid. In case of the nucleotide breakdown, you all know that once the ATP is broken down, it results in the formation of IMP, which again results in the formation of hypoxanthine. Catepsin and calapine, which you know, which again acts on the proteins that causes the softening of the muscles, and then gaping, which again you know that is the connective tissue will lose their contact. That means it forms in the form of loose structure, that is gaping. TMAO demethylase is the reduction of TMAO, which results in the formation of formaldehyde. Next, regarding the fish, which fish has to be selected for cooking. So you have three stages, that is pre-rigor, rigor and post-rigor. So the pre-rigor, if you try to cook it, you will get a soft type of soft structured meat. If you try to cook in the rigor stage, you will get a tough structured meat. If you try to cook in a post-rigor stage, you will try to get a firm and elastic and a very good textured meat. So you always have to choose a fish which is having in post-rigor stage. And next, regarding the K values, I think we all know about this K value. So it will usually expresses the freshness of the fish, and that again, the lower the K value, the high good quality fish. That is because the K value, as you know, you can see here hypoxanthine is present in the upper digit. That means the hypoxanthine concentration, if it is high, that means it is not a good quality fish. So the lower the K value, the freshness of the fish is good, and it is the one which is responsible for the better taste in the fish, and IMP that is the one which is responsible for the good flavor which you are getting, the seaweed flavor what you are getting, that is responsible by the IMP. So this is how the nucleotide will break down. The ATP will break down, the ADP again breaks down to AMP, IMP, and finally you get the hypoxanthine. which is not a good product. Next, these are the three methods. So as you can see in the photos, you can understand like this: bulking, shelving, and boxing. You all know the ratio of ice and fish should be 1:1, and in case of all the cases, bulking, shelving, and boxing, there is a layer of ice. Then that a layer of ice is followed by a layer of fish, and then again there is a layer of ice followed by a layer of fish. So bulking and boxing is almost same. That means only difference is that in case of bulking, you are using the wooden shelf, like wooden thing is kept in between the two sections. In case of boxing, you keep box between two sections. So in both the cases, the bottom thickness of the ice is 5 centimeters. You keep many layer of fish and ice. So once the height is around 45 centimeters, you keep one wooden shelf in case of bulking. Here, once the box is filled, you cover it with ice. Only in case of shelving, there is between the shelf, you are having only one layer of fish. In both bulking and boxing, you have a container. You keep one layer of ice, one layer of fish, again layer of ice, again layer of fish, until the desired length is achieved. Then you cover it with ice. In case of shelving, it is not like that. You put a layer of ice, then you put a layer of fish, a layer of ice, finish. It goes on like that. So in shelving, you only go for only one layer of fish. Because of that, it is a more suited method compared to bulking and boxing. So these are the different type of ice: block ice, flake ice, plate ice, and tube ice. Block ice, it has got it requires very long time to form. That is around 16 to 24 hours. It is obtained from the brine solution. And in case of flake ice, it forms like the one which you usually obtain in our laboratory or in our processing hall, that is flake ice. The thickness is around 2 to 3 millimeters. The plate ice, they have a thickness, as you can see in the diagram, it is around 8 to 15 centimeters. You usually cut down when it comes from the machine. In case of tube ice, they will be in the form of tubes. I think tube ice is the one which is mostly used in the processing industries for their function, for their work and other things. And they have a diameter of 15 millimeter, and the thickness is around 10 to 12 millimeter. And these are some of the points. So if you are talking about the seawater density, it is 1.027 kg, and then the specific heat of the seawater is a bit less when compared to that of the normal water, that is 0.94 kilocalories. That of the water is 1 kilocalories. And then, so the super chilling or a partial freezing is a phenomena when you try to lower the temperature between from 0 to -4 degrees Celsius. When the temperature of the fish is reduced from 0 to -4 degrees Celsius, then it is called a super chill. That means it is less than 0 degrees Celsius. So the freezing point of seawater is -3 degrees Celsius, and the freezing point of normal water is 0 degrees Celsius. Next are the two terms, CSW, RSW. Which you have already heard, I guess. RSW is nothing but refrigerated seawater. CSW is nothing but it is the chilled seawater. RSW, that is refrigerated seawater. As the name indicates, you are refrigerating or you are trying to cool the seawater. That means in case of RSW, the vessel, it will go for its fish catching. When it is in the ocean, it will try to pump the seawater, and it will try to refrigerate, and it will reduce the temperature of the seawater. And that cold water, it is used for chilling of the fish. So they are trying to save most of the energy. If the vessel is going for 1 month, 6 months and all, during that time, they are trying to maintain the temperature of the fish through chilling by using refrigerated seawater. In case of chilled seawater, again, as the name says, you are chilling the seawater. That means you are trying to reduce the temperature of the seawater with the help of ice. Again, the ratio of ice to seawater may be 1:1 or 1:2. So by using the ice, you are trying to reduce the seawater temperature. That is chill seawater temperature. You are refrigerating the seawater, that is RSW. In both the cases, they are trying to increase the quality of the fish during the long voyage. -1 to -5 degrees Celsius. So when you keep a fish for freezing, you know the fish will be normally having around 20 degrees Celsius. So the freezing is divided in 3 stages. So the first is the initial falling rate, where the temperature will try to reduce up to 0 degrees Celsius. So up to 0 degrees Celsius, there is no ice formation is taking place, because once after 0 degrees Celsius only you can see the formation of ice. So the second stage is called as the thermal arrest period. Why it is called as thermal arrest period is that here the fish stays in this stage for longer time. At the same time, most of the water is converted into ice. Around 3 part of the water is converted into ice. That is at -1 degree Celsius. That is the thermal arrest period. And next it is called as the final falling rate. That means the temperature is further reduced after the third stage. And here the temperature will reduce from -5 to -5 degrees Celsius. Here you can see the freezing or the most ice crystal formation is also seen in this stage. Here most of the water, around 80% of the water is converted into frozen stage. That is called critical range. Critical range is between -1 to -5 degrees Celsius, which is seen in the third stage, and that is the critical stage, where you can see the conversion of around 80% of water. In case of thermal arrest, there is the most ice crystal formation is seen, but the conversion, most amount of the water will convert in the critical range. And you know about free water and bound water. So even at -30 degrees Celsius, if you freeze the fish, the conversion of water into in a frozen state, it is very complete freezing of water is very difficult to achieve. So around 10% of the water still remains in the unfrozen stage. So if you want to have a good shelf life of the fish, you always have to freeze the fish to a core temperature of -18 degrees Celsius and have to store the fish at about -20 degrees Celsius. So -18 core temperature, storage is -20 degrees Celsius. Next is silent freezer. So air glass freezer, plate freezer, and liquid nitrogen freezer. So air glass freezer, we are using air for the freezing activity, and speed of air is around 5 meters per second. In case of plate freezer, we are using the help of plate for freezing activity, and again it is divided into horizontal plate freezer, vertical plate freezer, and the vertical plate freezer is the one which is usually used in the vessel to carry out the freezing activity. In case of liquid nitrogen, we are using liquid nitrogen gas in order to carry out the freezing activity, and as you know, the cost is very, even though the efficiency is good with liquid nitrogen, the cost is very costly. At the same time, during the storage, the liquid nitrogen will get lost. That means the will get decrease with the storage. And these are the refrigerants. Also, the primary refrigerants are the ones which you can directly use for refrigeration. Secondary refrigerants are the ones which has when you can't use some of the refrigerant direct content. So with the help of secondary refrigerant, they act like a medium between the product and the mean refrigerant. So that is called secondary refrigerant. And ammonia, carbon dioxide, sulfur dioxide, water, and air. And freon groups are the other refrigerants which are usually used in your normal home refrigerators. They are usually non-toxic, non-flammable, and they are non-corrosive. Because of that purpose, we use them. And again, these are some of the points. You all know about drip loss. Drip loss is nothing but the loss of weight during storage fishes, and that can be prevented with the help of polyphosphate. And usually we use less than 4%. So then, coming for the freeze drying. Freeze drying will work on the principle of sublimation. There is a conversion from solid to vapor stage, and the moisture is reduced up to 2%. So the shelf life of this type of product is more than 12 months. And as you know, at -1 degree Celsius, most of the crystallization takes place. And in order to measure the oxidation of lipids, we have to produce that is peroxide value or thiobarbitric acid value. So the peroxide value will help us to determine the primary oxidant, that is aldehyde and ketones. In case of the thiobarbitric acid, which helps us to determine the value with help of malonyl that causes the formation of melanin, which is a black color pigment which is found in ships and lobster. And how do you control this melanin, which you all know, which we are using sodium metabisulfate in order to prevent this melanin. So next is canning. I'll try to go fast. So the canning, as you can see, this is nothing but this is the can anyone see who is in that photo? Okay. So the canning was invented by Francis Crick, and then he is the one who is the founder of tapetization. And then in 1810, we do had the Peter Durand is the one who came up with the tin plate for the production of canning. So the one upward, he used the glass bottles for the production of canned products, and for that he even got awarded by the French. In 1900, we do have the double steaming was invented by the Max and Charles. So this is the difference between pasteurization and sterilization. So pasteurization usually takes place less than 100 degrees Celsius. Sterilization will take place more than 100 degrees Celsius. Sterilization aims at complete destruction of microbes. Pasteurization helps. It aims at partial destruction of microbes. So the shelf life in case of sterilization, it is less when compared to that of the sterilization. Mainly we try to achieve vacuum in the cans in order to prevent the growth of microbes, and the storage temperature is 20 to 30 degrees Celsius, so there is no presence of thermophiles. And in fishery product, we mainly aim at preventing Clostridium botulinum, and we try to achieve commercial sterility. Commercial sterility means we are trying to eliminate most pathogenic organisms. Absolute sterility is a condition where you are trying to eliminate all the microbes from a product. Thermobacteriology, you are trying to determine the properties of the bacteria, that is thermobacteriology. Next, unit operation, which you know. So I try to deal with some of the points associated with the unit operation. So if you are talking about blanching, again, blanching helps in inactivating the enzymes, and it improves the property and texture of the product. So the cold blanching, we use around 10 to 15% of brine, and for hot blanching we use 5 to 6% of brine. And pre-cooking is a condition. In order to prevent the curd formation, we do try to go for pre-cooking, especially in case of some of the fish product, that helps in reduction of the moisture and prevents the formation of the curd. And if you are using a salt as a filling medium in cans, we usually use it a percent between 1 to 3%. And filling media, you can fill the depending the types how it is filled, it will also changes. In case of tuna, you can use chunks and flakes. In case of crab, you usually pack in the form of flakes. Whenever you pack, it's very important to remember the head space, because the head space is very important in the can, and that causes the spoilage in cans. All the main aim is also head space is to have a vacuum. With a proper vacuum has to be achieved, and at the same time the properties of the compound is preserved. So if the head space is not maintained, the vacuum may be disturbed. At the same time, it may also disturb the properties of the food. So these are some of the trade name and dimensions of the cans. So the difference between natural style and dry packing is that in case of natural style, you are not going for pre-cooking. In case of dry packing, you are going for pre-cooking. In both the cases, you are not using any of the liquid medium. You are only packing acid. So when they will go for autoclaving, whatever the liquid released by the product, that only will act as a liquid medium. So in case of open sanitary cans, we are using the tin plate around 98%. It is made up of tin plate, which consists of 98% of steel and 2% of the tin. And we all know we should always have a lacquering for a cans in order to prevent the discoloration which is caused in the cans. And the lacquering thickness, which usually ranges from 2.5 to 8 gram per meter square. And again, the lacquer is divided into two types, that is acid resistant lacquer and sulfur resistant lacquer. And for acid resistant lacquer, the name is called AR-NML, and for sulfur resistant, we call CNML or SR-NML. For fish, we are using sulfur resistant lacquer. In case of exhausting, we are trying to replace the air with the help of we're trying to replace the air and create a steam, so that when you go for after double steaming, it is converted into vacuum. After thermal processing, it is converted into vacuum. And here when you go for this exhausting, it is divided into heat, mechanical and steam injection. So the most preferred method is heat type of exhausting. So the clinching is nothing but whenever you go for exhausting, you will try to close partially the can lid and the can body. That is called as clinching. That is the partial closing, and then you subject it so that the air is replaced by the steam. So on cooling, it will turn into vacuum. So exhausting is done at around 60 to 70 degrees Celsius. And these are the head spreads which are present in small, medium and large cans. And regarding the folds which are present, that is the metal folds in the cans, altogether it has got 5 folds, 3 because of body and 2 because of body and 3 because of the lid. And minimum overlapping when you go for double sealing, it should have a minimum percentage of 45%. Regarding the thermal processing, the thermal processing depends upon the acidity of the food. And as you can see, the fish comes under the low acidic food, so you are going for sterilization at about 121 degrees Celsius. And then regarding can washing, you are using sodium polyphosphate after you are going for exhausting. You have to wash the can before you go for thermal processing. Thermal processing is a condition where you are subjecting a can to determine time and temperature, so that it will eradicate the pathogenic and spoilage microbes. That is nothing but it is a come up time. Whenever you subject a can for thermal processing, you do have to wait until it will achieve a proper temperature and pressure. Then only you should start to count your time. That time required to achieve the required temperature and pressure, that is 121 degrees Celsius or 15 psi pressure, that is called as the cut. And usually the heating media which is used is steam, and the dye steam is not good because it doesn't have a proper transfer of heat. So you always go for the saturated steam. The first diagram is regarding the hydrostatic type of heating thermal processing, where you are trying to achieve the sterility in the cans with the help of water which is keeping at a high pressure. That is usually in the shape of W, and or else normally use red dot, or else you normally use autoclaves. So after that you usually go for cooling of cans. Why you do cooling of cans? The first thing is that on cooling the steam gets converted into vacuum. Secondly is that it will prevent overcooking and it will prevent the formation of any thermophores. And then the can has to be preserved for maturation at least 1 to 3 months, so that before they go for marketing. And if you are storing the can's assets without cooling, that results in the formation of static bugs. Next, regarding these 3 terms, D value, TTT curve, Z value and survivor curve. D value, D value is nothing but a time that is required for 90% reduction of microbes in your compound. So when you plot a graph with the number of bacteria and along with the time, that is called a survivor curve. Because reciprocal of that survivor curve is always the D value. TDT curve is nothing but it is the time required for the complete destruction of bacteria. In case of D value, there is a reduction of 90%. In case of TDT, you are trying to destroy complete bacteria. Z value is nothing but it is the temperature that is required for the TDT curve to pass through one log cycle. So what is the temperature that is required? That is called as Z value. So D value indicates the thermal resistance and Z value indicates the temperature sensitivity. So next is F0 and F0. The definition is same as the TDT. So here the thing with F0 is that the timing, the temperature, the sterilization temperature is very specific. That means they are using the organisms at about 250 degrees Fahrenheit. And the Z value will be equal to 18 degrees Celsius or 10 degrees Celsius, 18 degrees Fahrenheit or 10 degrees Celsius, and the sterilization temperature will be 250 degrees Celsius or 121 degrees Celsius, 250 degrees Fahrenheit, sorry. Next is regarding cold spot. In case of the solids, there is a conduction, and the cold spot is usually from the geometric center of the cans. In case of convention, the cold spot is formed at 50% above from the cans, that is usually seen in liquids. In case of F0 value for Clostridium botulinum is 2.4 minutes, that is the minimum botulinum cook. And these are the D values, and these are the organisms which are found. I think you can find this table anywhere, any code or in Excel or anywhere. You can refer there, I guess. And regarding the spoilers, the Bacillus stereothermophilus is associated with the flat spore for spoilage. Then Sarcoplasmic is because of Clostridium agrificans. And if you are talking about Clostridium botulinum, it's the mesophile, and it requires a particular pH for the production of the toxin. That is, the pH should be more than 4.5 for the production of the Clostridium botulinum toxin. In case of Bacillus stereothermophilus, even though there is a high chances of association of our product with Bacillus stereothermophilus, we have to make a hygiene condition so that we are avoiding that bacteria in our product. And regarding the chlorination, we can use sodium hypochlorite or calcium hypochlorite. The chlorination works in such a way that in presence of water, it will dissociate to form the hydrochloric acid or HCl. So that results in the destruction of the cells or the spores which are present in the product. Next, these are some of the ppm which are used for the cleaning purpose. And even for can cleaning, you should always use a potable water once the cans are done, packed, and vacuumed and other. Next, these are some of the spoilers associated with the canning. So as the name suggests, flipper and springer, in both the cases the pressure inside the can is more. In case of springer, the pressure is more compared to the flipper. In case of flipper, the can flips out. In case of springer, there is a formation of convex formed on the can. When you press on one side, the other side flips out. In case of soft cell, there is the convex end. When you press it, it will become a flat surface, but when you remove the pressure, again there is a formation of that convex end. Hard cell, you cannot press that convex end whatever it is formed. Paneling is a condition which is formed inside the rotor because of the disturbance of vacuum. And regarding spoilage, we have got sulfide, blue discoloration, curd formation. In case of sulfide blackening, it is again because of the association with the sulfur containing amino acid in the can, in the canned products, along with touch of iron which is present in the can. So the can contains the iron, and our product contains the sulfur containing compounds. When they combine together, there is a formation of the iron sulfide that results in the formation of black discoloration. Blue discoloration takes place because usually seen in the crab product. Again, it is also because of sulfur containing compound and the copper that is present in the blood of the crab. They both react in the formation of the copper sulfide. In case of curd adhesion, that is because of the coagulation of protein, which is again seen in salmon and mackerel. But as we have discussed before, pre-cooking helps in removing of the curd formation from the product. Honeycombing is associated with the tuna. Whenever you use a not good product, that will result in the formation of honeycombing. Retort bond, when you store when you are not cooling the cans properly, that will result in the formation of retort bond. And case hardening is a condition when you are not using the liquid medium in a proper condition. Like the solid to liquid ratio is not properly maintained. The liquid ratio is not good, so that causes the dehydration in the cans, and that causes the formation of case hardening. Struvite is nothing but it is the magnesium ammonium phosphate hexahydrate. Usually they are not dangerous, but still people don't like it. They are nothing but they are the glass crystals which are formed, and they are because of not good quality raw material when we are using, or there is presence of magnesium in the salt. We have to use chelating agent in order to avoid the struvite formation in our can product. Next, regarding the retort pouch, retort pouch is either 3 or 4 laminated. So it consists of the polyester, aluminium, and polypropylene. So the inner one is polypropylene, the middle is aluminium and polyester. So as the layer represents polyester, it is very good for printing and other things. Aluminium, it helps in preventing the light, air, and gas. Polypropylene, it helps in protecting the product integrity. And the difference between the retort pouch and the can is that the time required for the thermal processing of the retort pouch is less compared to cans. In case of here, we are using only 40 to 45 minutes for the thermal processing of the retort pouch because of their structure. They they complete the thermal processing in a very fast way. Next, these are some of the charts for bacteria, so which you already know, I guess. The classification based on the temperature. We're having cyclophils, which are cold loving, mesophiles, thermophiles, and hyperthermophiles. And the cyclophiles are the ones which are called as cold loving. Cyclophobes are the ones which are cold tolerant. And marine fishes usually consist of more amount of gram positive, gram negative. Freshwater fishes consist of gram positive. Brackish water consists of both gram positive and gram negative. These are the dominant bacteria. Regarding the difference between gram positive and gram negative, so the gram positive are the ones which are usually purple in color, and gram negative are the ones which are pink and red in color. In case of gram positive, you do have a thick peptidoglycan layer. Gram negative has thin layer. Glycogen is present in gram negative. It is not present in gram positive. Teichoic acid is present in gram positive. It is not present in gram negative. And regarding the limits, this I wanted to say. If you are talking about the CPC in case of water, which is used for the processing plant or any way, when at 22 degrees Celsius, 100 per ml is acceptable. At 37 degrees Celsius, CPC value of water, the limit range is 20 per ml. And these are some of the values. So as you can see here, the salmonella and vibrio has to be present in for 25 gram. E. coli is accepted for fresh fish at 10 per gram. And in case of frozen fish, it is 20. The heavy metals ranges are for mercury, it is 0.1. And then if you are talking about pesticides and insecticides, it should be at 0.01 milligram per kg. And histamine should be around 200 ppm. And histamine value, again, it depends upon the policy which you are trying to follow. Like for example, if you are having codex, if you are having XSSR, based on the country, the requirement may also change. And regarding difference between pour plate and spread plate, as the name indicates, in case of spread plate, we are using 0.1 ml. In case of pour plate, we are using 1 ml of the inoculum. In case of pour plate, either you are mixing the inoculum along with the medium and pouring, or you are pouring first the inoculum and over that you are pouring your medium. I think the diagram is a bit clear one. In case of spread plate, you are using you are trying to spread with the help of glass spreader, and the colonies formed in case of the pour plate is both in case of the surface and subsurface. It will support both aerobes and anaerobes. In case of spread plate, it can only support the aerobic bacteria, not the anaerobic or the anaerobic bacteria, and the colonies are only found on the surface. And regarding the toxins, so we are having DSP, PSP, ASP, and NSP. These are the surface poisons, and almost all are associated with the dinoflagellates. ESP, that is amniotic fish poisoning, is the one which is associated with the diatom. And as you can see, the algae which we have listed in the second table, and the DSP is the one where having the toxin, the possible toxin is opadic acid, and algae associated with that is dinophysis. And then PSP, where having saxitoxin, the algae associated with that, it is Alexandrium. In case of ASP, we are having bromic acid, and the algae associated with that is Pseudonistia species. Thank you. So I know we do have a very less time, it's only 15 minutes, but this is all the content what we are studying or through the question bank. Everything is the one which you have already studied for 4 years. So I think you can do good. So don't worry or don't get tense. Studying in a very calm way. Thank you.
Yeah, thank you very much, Sahana. So it was an exhaustive talk, exhaustive presentation. You have covered all the things. You have touched all the things. So can you share the PDF?
Hello? Chanikya, mute.
Okay, thank you very much, Sahana. It was exhaustive presentation. So can you share the PDF?
Yeah, I'll do that.
Okay, we know that we have already took 1.5 hour, 1 hour 10 minutes. So what we will do, I will take 10 more minutes I will just give a quick rapid revision, like what previously they have asked, what are the important things. I will club those related things together, and I will just read it out. So nothing will be in slides. I will just read out. So be attentive for 10 more minutes. So I will just go quickly. What are the things you have to focus on? So here we go. Like many papers they have asked, why fish is highly perishable. So you have means the reasons are due to high moisture content, more percent of unsaturated fats, low glycogen reserves, low connective tissue. So these are the reasons why fish is highly perishable. And how chilling preserves the fish. So chilling takes the temperature near to 0 degree centigrade. Don't confuse. So chilling will take fish temperature near to 0, not 0 or below 0. So 1 degree or 2 degree centigrade, plus 1 or 2 degree centigrade, chilling will keep the fish. And what is the mechanism of chilling? Means delaying the biochemical and microbial processes and extending the lag period of microbes. So this is the mechanism of the chilling. Then freezing. What is the mechanism of freezing? They have asked multiple times. So mechanical rupture of bacterial cells during ice formation. So that is the mechanism of preservation of freezing. And in freezing, how you can eradicate oxidative rancidity? So the answer is glazing before freezing. By glazing before freezing, you can prevent the oxidative rancidity. Next, they have asked multiple times, smoking. So what is the mechanism of preservation of smoking? They will ask. You have to just answer. It is by depositing bacteriostatic chemicals like formaldehyde, phenols in the system. So bacteriostatic chemicals like formaldehyde, phenols, in the smoke, these chemicals will be present. These are the chemicals which are responsible for the preservation. So they have asked 2 times, if equal mass of salt and sucrose is used for storage, is used for preservation, which will have more preservative effect. So the answer is salt. Equal mass of salt and sucrose, if you are used, salt will have more preservative effect. And if you see the term hermetically sealed container pouches, you just answer it is a retort pouch. And if they are adding sterility 121 degrees centigrade, then canning. And majority of Clostridium botulinum, high heat resistant, high radiation resistant. If they ask marination, the answer will be acidic medium, pH 4.5. Acids involved in the marination are acetic acid and propionic acid. If they ask irradiation, the mechanism of irradiation is DNA damage, and the process is electromagnetic radiation and electron beam. So X-rays, gamma rays, and electron beam. If they ask for a freeze drying, you may all know sublimation is the answer. Sublimation is the mechanism for freeze drying. And sometimes they have asked no intermediate thawing, excellent stability, satisfactory rehydration, and convenient for transport. So all these are the features of freeze drying. If they ask combined methods, combination of barrier technology, a series of preservation factors, then the answer is Huddle technology. So salting and drying are the traditional methods. What is the mechanism of salting and drying? Means reducing the water activity. And they are asking in which method of preservation original shape is not retained. It is fermentation. So which will slow down means by salting, which will slow down the process of salting? The answer is impurities like calcium and magnesium chlorides. And they have asked which is hygroscopic in calcium chloride and magnesium chloride. The answer is magnesium chloride. Magnesium chloride is hygroscopic. Sana, can you go next slide? So, and they have asked multiple times, what is the causative factor for red and pink spoilage? The answer is halophilic bacteria. Staphylococcus sarcina, halophilic bacteria. Dune spoilage is due to halophilic molds, and again it will on salted products. So dune spoilage is due to halophilic molds. Halophilic mold example is Wallimia. So in one paper they have asked what is Wallimia. The answer is it is an osmophilic mold. And they have asked dry salting. What is the ratio of salt to fish? So 1:3 to 1:10. They have asked what is the moisture content in wet salting? So 50 to 55%. What is the salt content in wet salting? 25%. So in pit curing, the ratio will be 1:4. Salt is 1, 4 will be fish. And if you heard the term Garcinia, Cambogia, tartaric acid, Sri Lanka, Southwest India, this is the preservation method is Colombo curing. So that is the thing, Colombo curing. And the factors, drying is directly proportional to air velocity, temperature and surface area. Drying rate is indirectly proportional. Like the drying means if the product thickness is increasing, drying will decrease. If the relative humidity in atmosphere is increasing, drying will decrease. And again, drying is having two phases: constant rate period, falling rate period. And one more thing they have asked multiple times: what is case hardening? So case hardening is surface is getting dried and inside it is moist. So case hardening will happen when there is a deposition of soluble proteins and other solutes on the surface. And you all know the different types of dryers. Then fish meal and fish powder. Most of the times fish meal and fish powder are dried in which type of dryer? So the answer is fluidized bed dryer. Fluidized bed dryer is the one in which fish meal and fish powder will be dried. Then the water activity of saturated brine solution, it is 0.75. Then they will ask what are the examples of halophilic bacteria, the halobacteria salinare sarcina, and halophobic bacteria. Pseudomonas is halophobic bacteria. And they have asked how we can reduce the pink spoilage. So the answer will be by using sodium metabisulfate. And the temperature of cold smoking is 30 degrees centigrade. Then comes products. We will see the fish products. Fish means, if they ask mince, people may confuse between mince and surmi. So if they ask mince is flesh separated from fish in a comminuted form, free from scale, skin and bones. That's it. If it is surmi, there will be an addition of cryoprotectants. So fish mince plus cryoprotectants is surmi. So different mince based products: fish finger, fish burger, fish cutlet. In fish, myofibrillar proteins are 65 to 80%. 3% are stromal proteins. And the kind of proteins which are not removed in the preparation of fish mince means stromal proteins and myofibrillar proteins. Sarcoplasmic proteins will get removed. So you may get confused. In the process of preparation of surmi, sarcoplasmic proteins will get removed. Stromal proteins and myofibrillar proteins will get remain. So concentrated myofibrillar proteins, if they ask, that is surmi is the answer. And examples of cryoprotectants: sucrose, sorbitol, polypropylene. And what is the rate, means how much we have to add as a cryoprotectants? 4%. Sucrose and sorbitol 4%. Polyphosphate, it is 0.3%. And how we have to measure gel strength? The answer is rheometer. How we have to measure whiteness meter, and the units for the measurement of whiteness is percentage Lovey bond. Standard whiteness means 93% Lovey bond. Folding test and teeth cutting test are used for measuring the springiness of the product. So those two tests are used for measuring springy test of the product. Crab leg, lobster, shrimp, scallop meat, etc. All these things are hybridized products. Kamaboko, chikua, hampen, all these things are needed products. So you remember, crab leg, lobster, all the normal things, they are hybridized products. Kamaboko, chikua, hampen, all these are needed products. So I will just tell the keywords. You have to remember, if they ask steamed product, it is kamaboko. If they ask broiled product, it is chikua. Boiled product, it is hampen. If they are asking only mixing and stuffing in PVC casings, then it is fish sausage and fish ham. So how you have to differentiate between fish ham and fish sausage is, in fish ham there will be smoke flavorings. In fish sausage only the meat will be stuffed in PVC casings. Then comes battered and breaded products. Here nothing more to learn. Just they will ask leavening agents, sodium carbonate. Biological leavening agent is yeast. Chemical leavening agent is sodium carbonate. Natural leavening agent is steam. Leavening agents of acids. Some acids. Can you add some acids like tartaric acid, potassium hydroxide tartaric, monocalcium phosphate. So these are chemicals, chemical leavening agents. And once they have asked what is the effective percentage of gums. So gums effective percentage is 0.5%, and more than 2% you can't add in as gums. So what is adhesive batter? So adhesive batter is the layer which will be added on breading. Adhesive batter, what is the difference between adhesive batter and tempura batter? Tempura batter, there will be there is an chemical raising agent. So what is the difference between adhesive batter and tempura batter means? In tempura batter, chemical raising agents will be there, and secondary coating may not be there. So first coating will be batter, second coating will be breading, and browning agent is directly proportional to reducing sugar. And different types of breadcrumbs, you all know. Reclaimed breadcrumb, if they ask reclaimed breadcrumb means it is an ordinary breadcrumb. Industrial breadcrumb, the defect is crust formation. Japanese style breadcrumb, you know the other names, Oriental breadcrumb or panko breadcrumb, it is flake like. So they may ask which is the flake like breadcrumb, it is Japanese style breadcrumb. The other names of Japanese style breadcrumb is Oriental or panko crumb. And extruded crumbs, high starch ingredients are extruded crumbs. And they may ask what is the process which makes surface area more conducive for addition, that is pre-dusting. And what is the moisture percentage of cracker meal? It is 8%. So cracker meal moisture percentage is 8%. Pre-frying temperature is 180 degrees to 190 degrees centigrade for 30 seconds. What is the triple point? At what point the triple point of water? It is 0 degree centigrade temperature and 0.006 bar. So 0 degree centigrade temperature and 0.66 bar. And if you see irradiation, they are asking what is the most commonly used gamma ray source. So cobalt 60 is the most commonly used gamma ray source. Cesium 137 is nuclear fission product. FISSION, nuclear fission product. So enzymatic product is due to polyphenol oxidase. Non-enzymatic browning is due to reducing sugar. So non-enzymatic browning, the other name is Maillard reaction. Freeze drying, the rehydration rate is up to 95%. Freeze drying mechanism is, we all know, sublimation. And previous, they have asked this multiple times. What is the previous unit of irradiation? So previous unit of irradiation is rad. So 1 rad is equal to 100 ergs. And now SI unit of radiation is gray. So you know all these things. So what is the thing irradiation can't affect? So irradiation can't affect enzymes and Clostridium botulinum spores. So these two you have to remember. Irradiation can't affect enzymes, enzyme linked spoilage and Clostridium botulinum spores. And Clostridium botulinum spores is most resistant to radiation. And they have asked many times what is the temperature that should be stored. If at all it is Clostridium botulinum, so it is 3.3 degrees centigrade. They will confuse by adding 2.3 degrees, 4.3. So the answer is 3.3 degrees centigrade. Temperature at which Clostridium botulinum won't produce toxins. So FAO WHO limit, maximum limit, what is the maximum permissible limit of irradiation is 10 kilo gray or 10 million electron volt of electron beams or 5 million electron volt of gamma radiation. Then we will see the packaging materials. So only the repeated questions, only the keywords I am telling, only those things which are important. So battered and breaded products we have to store in thermoformed trays of polyvalent chloride and polystyrene. So you have to remember thermoformed trays for battered and breaded products. So dried fish, what is the packing material means? Polyester plus low density polyethylene, LDPE. Salted and smoked fish you have to store in polyamide and polyethylene. So this is all about packaging material. So what they have asked, what is EVA? So EVA is a combination of copolymerization of LDPE and vinyl acetate. So this is one. And polyamide, it is a combination of diacids and diamines. Nylon 6,6 is the first polyamide produced. So they have asked this repeatedly. So we have studied this thing and we will go for byproducts. So the final part, just 5 more minutes. So fish meal, they asked fish meal, what is the specialty of fish meal? Fish meal has high levels of methionine, lysine and cysteine, MLC. It is also having B12, it is also having calcium, phosphorus, iron, copper and unknown growth factors. You have to remember all these things. They have asked repeatedly this thing. So what is the difference between wet rendering, dry rendering? Wet rendering is the process of preparation of fish meal exclusively for high fat fish. Dry rendering, low fat fish. So press cake consists of 50 to 55% moisture, 3 to 4% oil. What is the name of the expelled liquid means? Press liquor. What is the name of clarified liquor means? Stick water. So press liquor means expelled liquid. Clarified liquor means stick water. So what is condensed fish solubles are made of 50% solid content. Fish meal is heated up to at what temperature? It is 80 degrees centigrade. Fish meal is heated up to 80 degrees centigrade. Fish meal should be stored at 35 degrees centigrade. Fish meal should be stored at 35 degrees centigrade. The level of fish meal in What is the moisture percentage? So it is 10% in both grade 1 and grade 2. So what is the protein percentage of in grade 1 means 60%, in grade 2 it is 50%. In everything, everything is same. So they will ask what is the protein percentage in grade 1 fish meal means 60%, grade 2 fish meal means 50%. Then comes fish protein concentrate. If at all you are seeing in the question gritty, colorless, odorless, tasteless powder, so it is fish protein concentrate. Again it is stable protein concentrate, no resemblance with original material. And the methods Viobin method we use ethylene chloride. Canadian process we use isopropyl alcohol. In both the process you have to remember one thing, like the azeotropic mixture of ethylene chloride and water, the boiling point is 71 degrees centigrade. In Canadian process, first stage you use an acid. They have asked what is the acid you use in the first stage of Canadian process of preparation of fish protein concentrate. The answer is phosphoric acid. So we Indians we use azeotropic mixture, azeotropic extraction method. So azeotropic extraction method use hexane and ethyl alcohol. So we use the acetic acid there. Indian method we use acetic acid. In Canadian process they use phosphoric acid. In British method they use ethyl alcohol for the preparation of fish protein concentrate. In Chile they use hexane followed by ethyl alcohol. So pepsin digestibility of fish protein concentrate, it is 98%. Remember this. Pepsin digestibility of fish protein concentrate is 98%. Moisture content of fish protein concentrate, it is 8%. Crude protein is 67.7%. How much is the acceptable limit in human diet of fish protein concentrate? It is 5 to 10%. Only 35 grams per person per day it is allowed for fish protein concentrate by WHO. And this you may all know, texturized fish protein concentrate, it is marine beef. And three types of livers, so cod and haddock liver, 4 to 9% of liver, and it consists of 48 to 70% of the liver oil content. So it is high oil, low vitamin latency. And shark has 10 to 25% body weight liver. So if they are asking in the question which organism has more liver composition, means it is shark. So shark liver, it has 60 to 75% oil. Then halibut, tuna and whale. So halibut, tuna and whale, there is only 1%. Their liver is only 1% of its body. It is having 4 to 25%. Its liver is having 4 to 25% of oil. But halibut, tuna and whale, it is of low oil, high vitamin A potency. So low oil, high vitamin A potency, halibut, tuna, and high oil, low vitamin A potency, you have to answer cod, haddock. So fish albumin, fish albumin is used, it is prepared by using 0.5% acetic acid. What is the difference between technical grade albumin and food grade albumin? You have to answer by digesting technical grade albumin in caustic soda, NaOH, we will get food grade albumin. Then peptones, intermediate product on the breakdown of proteins is peptone. Liquefied fish protein is fish silase. Mixing fish waste with hydrogen like sulfuric acid or formic acid or by lactic acid bacteria, you can produce fish silage. Then how you can produce fish leather means by treating fish skin with calcium hydroxide. Shark fin. So how you process shark fin means by adding 10% glacial acetic acid. So all these are the repeated questions I am just spelling out. And shark cartilage, it is chondroitin sulfate. The chemical structure of shark cartilage, it is chondroitin sulfate. Then chitin, chitosan. So chitin is the second most abundant organic compound. It is a very tough structure. It is insoluble. So chitin, how it will be means how they will make chitin means they will take fish, the shrimp shell waste. They will first demineralize it with hydrochloric acid, 1.2 N hydrochloric acid. Then they will deproteinize it with 5% caustic soda. Then we will get chitin. So how they prepare chitosan means they will deacetylate chitin. They will get chitosan. So the name of chitosan is deacetylized chitin. So it is what is the difference between chitin and chitosan is chitin is a tough structure. It is insoluble, but chitosan it is a loose structure. Chitosan is soluble in dilute acids. So as a formula, chitin plus 40% caustic soda is equal to chitosan. Chitin plus 10 normal HCl is equal to glucosamine hydrochloride. So again squalene C30H50 the formula, and 85% squalene has 85% of unsaponifiable portion. Ambergris, sperm whale, horny beak of cuttlefish, aphrodisiac. So these are the things which are repeated multiple times. So I just read it, I just went quickly through them. So apart from this, most of the things Sahana has covered. Sahana, can you remove that thing? Can you stop sharing?
No, sir. I have
Yeah, most of the things Sana has covered, and rest the things I have dealt. What are the repeated questions? So with this, maybe majority of the questions, 80 to 90% will cover. Will get covered in these things. So maybe remember all the bacterias, remember all the temperatures, the mechanisms. So apart from that, from processing, maybe apart from this, very rarely they will go out. So purely memory based. So you have to just revise. Maybe what we have discussed, what Sana has discussed, what I have just read out now. Maybe you all may be knowing this. Yeah, we will share the slides with you. But what was my intention is, like majority of the things what we have shared today, what she has spoken, what I have spoken, maybe you all may be knowing this, but we want to make you just revise the things. We want to you to remember the things. So maybe you have read 2 days back or 1 month back or 2 months back. So these are all the key concepts. There is no need to worry. So with this, maybe majority of the fish processing thing, approximately 80 to 90% of the questions we have covered. So maybe if you are having still any more doubts, you can put that in chat box, and I can see many people, they are very active in chat box, they are answering the questions. We highly appreciate the acts. And one more thing is, like, sir, can you please share? Yes, what I have read out, I will share you. Maybe we don't have any Telegram group, so I will give that to in Step 2 Fisheries or someone, they will share with you. And this Saturday and Sunday we will be having aquaculture and pathology final revision. So with this all the major subjects will be covered. So by this Saturday, by this weekend, all the major things we have already did, the FRM, AEM, now pathology. So we will share all these things in Telegram group. Yeah, we are trying to create the Telegram group. Thank you everyone, because it's a long thing, like from almost 2 hours you all are there. So we highly appreciate your patience, even though what we are telling is maybe repetitive, maybe you already maybe knowing these things, but still our intention is to revise. Our intention is not to bring some new concepts or new things. Just we want to make you revise the things. Just we want to make your subconscious memory to active memory. Yeah, thank you everyone. Many people are active in the chat, so we highly appreciate the things. And this weekend, I am again telling you, this weekend we are going to cover the aquaculture and pathology. Senior PhD scholars, they will come and they may revise the things. Sana, do you have anything to say?
Yeah, I was just checking the chat box, and I'm very happy that many of you have replied to my questions. And all the best, do well. And it's really nice that you guys were still here. It was really a long presentation. And nothing much, Chanikya.
At the end of every session, I used to say the same thing: keep the things simple. At this point of time, you came a long way. You have spent 4 years. You have written all the exams, so no need to worry. Just we are here to revise some things. You try to do the mock tests or whatever the resources you are having, you can do that. We wish you very all the best, and there is no need make the things simple. So keep the things as it is. Don't make complex at this point of time. Don't lose confidence. So be very confident, be very free, spend some time with your family, have a good sleep cycle. So at the end of every session, I will repeat the same things. So keep your metabolism good. Don't have any health things at this time. So this time is very crucial. In the sense, I'm not suggesting you to study 12 hours or 20 hours per day. So be calm. Like as I have said repeatedly, see the things in a simple way. Keep the things very simple. So we are here to help you. We are here to revise the things for you. Yeah. Anyone want to speak anything? Yeah, and we will share the things. We will share the resources in the Telegram groups where majority of you people will be there. Yeah, thank you everyone. It's almost 2 hours, so we highly appreciate your patience. This Saturday, Sunday again we'll meet one last time. So yeah, take care of your health, and yeah, thank you everyone. Take care of your health. Have a good sleep cycle. Yeah, revise the things. Just revise the things. Be confident. You know everything. You have already spent 4 years, so there is no need to worry. Like what others do, you don't worry. You don't count what others are doing. Your thing is what you know. How good you are applying your what you have learned. So be confident. Thank you everyone. Thank you. Shall we close, Sana?
Also,
Thank you everyone. Good night. Take
good
care of your
night.
health. Have a good sleep cycle. These 15 days it is very crucial. Don't have any health issues. Take care. Yeah.
Bye-bye.
We'll both
Good night.
we'll meet again this Saturday and Sunday. So we'll try to cover the aquaculture and pathology part. With that, one last time we will meet, and with that we will finish all the major things. Thank you everyone.
Good night. Good night all.
Good
Bye.
night. Good night. Thank you.